In the previous video, we have studied about limits, what limits are, and how can we evaluate limits using table, graph, and algebra. In this video, we're going to study about the laws of limits. To study about this, first we must take an assumption that if we have two functions f of x and g of x, then if the limit for both of the function exists, then only we can apply the limit laws. Moreover, we must assume that c is a constant number. The first law says limit of a sum is equal to sum of limits. For simplicity, I'm gonna denote function fx as a, whereas g of x as p. The first law says limit of a sum is equal to sum of limits. For example, if we take two functions a and b in addition, and then we take the limit for them, what we can do is we can individually take the limit for function a and that of b. Limit as x approaches to small a of function a plus limit of function b. The second one is just same that of first one. The only difference is that instead of addition, there is subtraction or difference. The third law is that the limit of a constant times a function is equal to the constant times the limit of a function. That is, if there is a function a and we multiply it with a constant term c, then we find the limit. What you can do is you can take a constant outside and find the limit for function a. The fourth law is if there are two functions, for example a and b, if they are in product, and then we take the limit for them, what you can do is you can take the limit separately, first to that of a function and then that of a b function. The fifth law is that if we have two functions, if they are in division, for example function a and b, but note that b should not be equal to 0. If it is equal to 0, then we cannot use the limit law. If we have two functions a divided by b, then we take the limit for them. What you can do is you can separately take the limit for function a divided by limit for function b. Remember that the denominator should not be equal to 0, otherwise you cannot take the limit. The sixth law is that says if, for example, we do have a function a raised to power some n is a positive integer, okay, then you're going to take the limit for this. What you can do is first you can find the limit for function a, then you can take the power. Okay, The seventh is that limit of a constant function when x approaches to a is constant. Let me show how it is. Let's suppose we do have a function that is, I've drawn this. This is a constant function because the y value does not change. If you want to find limit at any point, let's suppose we want to find at this point. Here you can see that the output for this is equal to c, constant function. Doesn't matter where we take the a. If you take it or here, it's always going to touch c. That means for any input, doesn't matter where we take it, the output is going to be a constant number, c. That means for a constant function, the limit of function is equal to what it is approaching to. Okay. For example, in this case, if it was here y, this is line y equal to 7, and you want to find limit or here a equal to 5, then the limit for this function when x approach to 5 will be equal to 7. Doesn't matter where we take the point a, the limit for function will be constant. And if we have, for example, if the eighth one is if we have a linear function is represented by a line. Okay, we know for a linear function y is equal to x. That means any point on this line will be equal. For example, the coordinates of this point, if for example coordinates of this point, that is x equal to 2, then the coordinates of y point will be also equal to 2. Doesn't matter. So you're gonna take limit over here, over here, over here. Okay, the output will be same to that of a point. For example, if it is a, the output will be a. If it is b, the output will be b. If it is c, for example, c, the output will be c. That means for a linear function where you are approaching to, the limit will be same to that of a number at which you're approaching. The last one is if we have a function x raised power n, then the limit will be equal to a raised power n. This 7th, 8th, and 9th are just similar. In the 8th case, the power was 1, and in the 9th one, the power is n. It's a general power. It could be 2, 3, 4. Okay, it's that it will be a raised power n, it will be a raised power 1. The 10th is if you're going to take limit, for example, root x, nth root of x, then it will be equal to nth root of root a at which it is approaching to. This is a linear function.